Everyone.
Hello. Hello. Yes. Hello, everybody. Thanks to be here. I am honored to help a little bit in this presentation of Paul. Paul-Mockapetris. Probably you guys don't know him, or probably yes. But what you should think is that every single time you send an email, you use his invention. Every time you browse a web page, you're using his invention. So from now over, think a little bit more in him. And we'd like to make it in a format in like 30-35 minutes of questions and answers to record digitally his thoughts for the future. Imagine that we are creating this experiment like a time capsule where we put all these ideas from the pioneers or why you did this. Imagine that we make a fast forward in 50 years from now. Somebody finds this interview, if this guy is recorded well, then we can see why he invented this. Imagine that you are thinking on Thomas Alva Edison or Graham Bell, saying, well, I invented this because that or because, and you can hear and listen them directly. That's the idea of this project, okay? So Paul, when were you born? Very personal.
1948.
And where?
Boston, Massachusetts.
And what did you study?
I went to high school at Boston Latin School, and then MIT, and then University of California at Irvine. And now I'm at the University of Pierre and Marie Curie in Paris.
In Paris, great. And do you remember when you had your first contact with a computer?
I do. MIT had classes for high school students during the summer, and my first computer was an IBM 1620 in the Department of Aero and Astro at MIT. And one day the secretary wanted to leave early, so she said, "You're a student, right?" And I said, "Yeah, I'm a student." And so she said, "Here's a key. You can come and go whenever you want." Now, she didn't ask me if I was a high school student or an MIT student, but I had the key.
I see. So you could go whenever you wanted, and that's fantastic. And what was your first contact or experience with the internet or the ARPANET or international network?
When I was at UC Irvine, they had dial-up capability because of Dave Farber to TIPS. And so I would connect to the ARPANET via a tip up at UCLA.
Directly. So you had access, and I see. And in your opinion, what are the key characteristics of the internet?
Well, I think the key characteristic of almost any technology is that you can't envision all the possible uses. People often ask me, well, when you designed the DNS, could you imagine that it would be used for all these different things? And I always say that's the wrong question. If I could have imagined all the possible uses, it wouldn't be the right design. You know, what we do is we try and design technology that solves existing problems today, but looks like it has applications for the future. So that when I designed the DNS, there was no web, so that URLs were not a problem. But we could use the technology for that and other things. And I think that's, you know, one of the things that happens with all internet technology. I was very struck by Bob Kahn and Vince Cerf when they were getting their prize, that they said, well, we could have never done this if anybody had understood how important the internet would become. We could never do IPT. The same thing was true of DNS. People thought it was a nice little problem of no consequence at the time, so that's how I got to solve it. So, you know, lots of times you don't understand the uses and the importance of a technology in the future, but you want to design something that's extensible and that doesn't limit people.
But the good thing is that you were there trying to solve the problem, right? And
yeah, the other characteristic is it has to be a technology you can understand. I think, you know, everybody sort of understands how domain names work, and so that's, you know, one of the reasons why it's easier to use domain names than quantum mechanics in the internet.
I see. And what do you consider the most important milestones in the development of the network?
I think there's been several errors that have happened, and each one of them has been triggered by a particular milestone. So, you know, there was IP-TCP, which made it possible to hook multiple networks together. But then there was also the provisioning of, say, you know, email routing via the DNS that made it possible for everybody to manage their own part of the network. Those were things that were early and very important. There's obviously the web, you know, and to some extent I think Facebook and LinkedIn and these other kinds of things are actually the implementation of the directory. People have had this idea that we need a directory for the internet for about 30 years. And they said, well, it's going to be X500. Well, it wasn't. But I think Facebook is, to some extent, the directory of the internet. Some of these other social networking things, I don't think they're quite there. But from a standpoint of giving everybody an internet identity, things like Facebook or things like the DNS are getting there. And, you know, we're going to need 7 billion identities soon. Not to mention the ones for my car and my refrigerator and everything else.
And if you had to summarize, how did you contribute to the development of the internet? What are you more proud of?
You know, the DNS today is, you know, I built the first floor and maybe the second floor of this, and then people have come along and added about 20 more floors. So the DNS is used for voice over IP phone calls, and it's used for RFID. And all sorts of things. And being able to build the next stage of something and let people continue on above you, I think is the key characteristic of the technology. So I started the first 2 floors, and then a bunch of other brilliant people have added many more.
So, but probably when you were working on that, you were focused on solving a problem, a small problem. Well, not really small, because that having the DNS allowed to the internet to scale, right?
Oh yeah, I mean, originally the job I had was, they said, here's 5 proposals for how to map names to addresses, one of which was a big central server in the middle of the US. We want you to just kind of make a joint proposal out of this. So I threw them all away and wrote something new, because it wasn't a very important problem at the time and I could get away with that. And because I had always believed in distributed solutions. So, you know, I think that, you know, being able to, as the commercial for the Internet Society said, innovate without permission, and building an infrastructure that allows you to do that is one of the key characteristics and things we should strive for.
And what do you think? Who are some key people in the development of the internet, leaders, trendsetters, from your point of view?
Oh, you know, there's too many. I mean, I tend to believe that there's an awful lot of people, and people, you know, oftentimes say, well, you know, you invented the DNS. The DNS is kind of a recipe in the sense that I didn't invent hierarchies and so forth. And, you know, a lot of people, you know, didn't invent particular ideas. They were pieces that they found, ingredients that other people had created that they make into a new recipe. So, you know, I think the really key turning points to my way of thinking were, you know, the whole idea of internet and gluing together separate networks, whether it's doing that with IP-TCP or DNS. I think that the idea of local area networks was a very important idea, and there were several people that did that. Metcalfe and Boggs. You know, I always tell Dave Boggs, insist on alphabetical order next time you file a patent.
Yeah, right.
You know, and I think more recently there's been all of the internet entrepreneurs, and I hate to start making a list because I'm going to leave some of the key ones off. But you have them all in your book.
Yeah. And tell us a couple of anecdotal situations, some, well, related to the development of the DNS or to your internet experience. Something that could be funny, that you were thinking to do something and then something else happened, or...
You know, there's a lot of... We were having an argument early on about whether or not all domain names should end in country codes or whether they should end in generics like .com and .edu and so forth. And I always argued that we should do both. and that you should be able to do some experiments and let people figure things out. So I think that was an interesting incident. I think the funny incident that I remember is my oldest son, one day as I was wheeling him around, a bus goes by, and I saw a URL on the side of the bus, and he goes, .com, Daddy did .com, which, you know, there's, the internet brings people together, and a lot of amusing things happen.
Yeah, exactly. And who decided the names, the .com, .mil, that was later, right? You invented the recipe, as you said, but later on, more, I would say, this political part of, say, .mil here, .com there, it was more decided later, or how it became all these things?
We could embarrass a lot of famous people here, but some people thought the top-level domain should all be country codes, like UK and US and ES and so forth. Others wanted to do generics. Another set of people said it should be the characters, so Telefonica should be a top-level domain along with MCI. Well, it doesn't exist anymore, but, you know. You know, a lot of people wanted to be able to put particular semantics in there. And what I finally wouldn't agree with any set of people, and I said we should just do both, except we shouldn't do the MCI as a top-level domain, even though some people wanted to. So, you know, I think that trying different ideas is basically one of the ways you innovate. I'm not sure I believe in the 1900 new ideas that ICANN is going to try. I'm sure there'll be some that are better or worse. But, you know, we'll learn and we'll move on.
You started this in 1983, right? More or less, 82, 83?
83 is when the first specs came out. We were thinking about it a little bit before that. Yeah.
Okay. And then the .com, .mil, the division of the domain space, when it took place? You remember?
Like around 1985 was
like a year later, right?
Yeah, I mean, that's sort of, I mean, once upon a time there was actually a .NATO top-level domain. Mm-hmm. And I said, I'm not sure there should be a NATO top-level domain. I managed to get that removed. But, you know, it's, the governance of this has been a little less experimental than perhaps I would have liked.
I can tell. But the idea, the first, do you remember the first domain? It was .arpa or
The first domain was .arpa simply because we said we'll take all the existing names, slap a .arpa on the end and put them in the table. All right, so it was a bootstrapping from the host table mechanism. But I think COM and EDU were all early on. The government representative approved .com only because he said, well, no one will use it, so I guess you can try it. I think he was a little bit wrong.
Yeah, exactly. That was just the opposite. That's why it's so interesting from a person who has been living all this development of such a key infrastructure like the DNS to say .com was like marginal, right? That's what at the beginning.
People thought that it wouldn't be. Some people thought it wouldn't be successful, which I found very amusing.
I can tell. And what do you think about the future of the internet?
Well, you know, there's been a trend in both semiconductors and in networking. You know that every time you put electronics in a device, whether it's a microphone or a microwave oven these days, you want to put a computer in it to control it, and the next thing you do is you put in some kind of network connection so that it can interact with other parts. So you know, people talk about how connected the internet is today, but I think we've only started. I think, you know, nobody knows what the Internet of Things really is going to be, but we know that more and more things are going to be interconnected, whether it's my car or, you know, the appliances in my house. And so being able to see the next 10 years of that, where I think more and more things will be integrated and hopefully controlled, and hopefully secure, I think is the real trend.
Well, at least this time we won't run out of addresses. I hope. With IPv6, there is always a saying that being served that with IPv6, every electron on Earth will have their own web page, right? It's not. That's what he says.
Yeah, well, yeah, there's also the idea that soon everything's going to go through port 80 because everybody lets, the web traffic go through. But I think that the IPv6 thing has potential to create a whole new era of innovation as you are allowed to give everything an individual address. We'll have to see on that.
Mm-hmm. And do you see, just to end, and then we could start 5-10 minutes of questions and answers from you, do you see any technological trends?
Well, I mean, I think the technology trends is that everything that has a computer will soon have a network interface. So that means that, your car has, I don't know, around 7 computers on the average in it. And, pretty much everything from my toaster to, on up has. So I think the question of integrating these things in a useful way is going to be the question. The trend has always been that computer power, and hence, since the network really is the computer, as Scott McNeely said, the tendency is to try and figure out how to put more pieces of data together to do something useful. And I think that's going to continue. Big data is just the most obvious commercial application of that. But I think, being able to have computers arrange my schedule better at the next campus party, for example, I think should be a trend.
I see. Okay. Thanks so much, Paul. Let's have some questions from you guys. There some questions for him? Over there.
How do you see this challenge in between companies to control the networks, and how do you think people are going to maintain their autonomy in this place? Because it looks like ISPs are feeling they have a lot of power and richness because they have the networks, and they are willing to control it and over-control it too much.
Yeah, there's people asked me to give a talk once upon a time about network neutrality, and I said, well, I don't know how I can do that because I don't think there is any. There's lots of fine points about network neutrality and how that should be implemented. It's not really out there today, and I think at the higher levels it's even more significant. So I think this whole question about to what extent we have this open and transparent internet, but on the other hand, we want to kind of keep certain companies from abusing that power. I think that's the big social issue of the next 20 years. There's specific things that we could talk about. For example, I don't quite understand why, if I'm in Switzerland, my Google data is more protected than if I'm in the U.S. Somebody from Google can explain that to me, I guess. And there's questions like, what are the rights of people to take their data off of these networks? Data that goes into a lot of these databases today just goes in. It never can be deleted, right or wrong. I think that's a governance issue, but I think that's really the open question. On the other hand, ISPs, we work with a lot of ISPs at Nomina, my company. For example, Telefonica is one of our customers. And what they ask us to do is they say, when people are using the DNS, should we advise people when they're about to go to an unsafe place? Or should we just say, oh, okay, yeah, we'll let you crash? How do you do that? And I think you have to, do ISPs have a responsibility to try and protect their users, particularly as their users get to be less and less sophisticated? Particularly with their devices, you have a computer there and it probably has a bunch of antivirus protections built into it. But if you go and get one of these handheld devices, well, not so much. What's the responsibility to protect? If you say you don't want your ISP to do anything, just let all the packets flow, that's okay, but is that the right model for everybody? So I think that's something we have to work out, and I think it's really one of the open issues right now.
More questions over there?
Hi. You said you see the future with everything being connected, and I think I agree with you. My question is really about how do you balance that with the issues of cyber terrorism? Do you hold back in that development because of the security issues and you know, for instance, all our grids could be taken down, you know, the fear of cybersecurity. So do you have a comment on whether we should just go ahead from a technical point of view and kind of forget about that and let that figure itself out, or do we hold back?
Yeah, I mean, you bring up an interesting question. Supposing you're worried about, I'm sorry, this sounds very weird to me. I hope you're hearing me. You know, protecting things like power grids and other kinds of infrastructure are obviously places where governments are going to have to act. But on the other hand, there's a lot of people that want to keep governments out of regulating the internet. So, you know, how do you deal with that? I think, personally, I think that the general user community wants to use facilities that haven't been made secure yet. People build apps long before they worry about making them secure. And functionality is always going to trump, from an economic point of view, security, because saying no to people. So I think that's what's going to happen is there are going to be some unpleasant incidents, and people will reevaluate those things. But we're always going to be a little bit ahead in functionality than security, and that's just, I'm sorry, that's the way people are. So, you know, I personally think that, you know, I'll speak for, you know, my government, the U.S., I personally think it's a great idea that they're trying to do some cyber protection of particularly these utility kinds of things. I'm very nervous about how they apply that to everyday traffic from every user and mining big data. And I think we'll have excesses in both directions before we figure out where it wants to be. And hopefully we won't have, you know, the $1 trillion problem show up. But I think we'll probably have $1 billion cyber attack may have already happened. Unfortunately, all we can do is muddle forward. I wish I had a clearer answer. If I was from the government, I'd just say, oh yes, we have a committee that will solve that problem.
Yes, there are two of them. And there is another one over there also.
Can you tell us something more about the work you've done after DNS in the last decades?
Well, sure. I'll give you a 100,000 foot view. Basically what happened was I did DNS work for a long time. And then I tried to get funding to do DNS security. And at the time, the National Science Foundation in the U.S. said, oh no, nobody cares about DNS security. So I said, well, gee, I don't have funding to do that anymore. And meanwhile, the people at ARPA said, well, why don't you come here and be a program manager? So I spent 3 years being a program manager and giving away money in Washington, D.C., which was an interesting thing. I went back to ISI, did a little bit more research. Didn't get funding for another idea I wanted to do, which was basically doing sonar to determine the structural integrity of buildings and bridges. And they said, oh no, we can't give you funding for that. So I got kind of bored and went to a startup called At Home that did the first internet over cable at a very large scale. Did another startup that did large scale email servers. And have been doing startups ever since. I came back to Nominum, which does DNS work, because I thought there was an opportunity to use DNS traffic as a source of big data and look for particular security threats and a bunch of other kind of new ideas in the way DNS is done on a large scale. Nominum does DNS for about 500 million users worldwide. So we get to look at a lot of that data. And we're trying to encourage people to think about that as one of the ways to observe what's going on in their network. Obviously, that puts us in the middle of a lot of privacy concerns, but there's questions about sort of detecting botnet infections and so forth, and what's the way you could go do that. So those are the kinds of things I've done, starting in DNS and then ending up in it again.
Hello. I think one of the problems is not only the security, also the traffic will be a problem in the future, because on the other hand, on the one hand, the business will pay for traffic, and maybe the user also, but then you have the problem that you get information only if you or the information giver has the money to pay for that. And we have areas on the world you can't have fast access to the internet, and also in Europe you have these areas, and with this immense traffic we make with sometimes stupid things, that will be a problem from the future, I think. Not only the security.
Yeah, it always amazes me. I live in Paris during the school year, and you know, what passes for broadband there is about 100 times faster than what I get in my house in the U.S. And I'm sure that, you know, there's places where there's no Wi-Fi, like just over there, but you know, I think that eventually a certain amount of communication is going to be viewed as being sort of entitlement for everybody. I think that what with the advances in fiber optics and radio technology, that we're going to be able to continue to see a bandwidth expansion. It'll be paid for in different ways in different parts of the world, which I think is one of the basic sources of conflict. But you know, I think more bandwidth is better.
Hi. Just want to ask you if you appreciate the massive arrival of new top-level domain names, actually.
It's an interesting phenomenon. You know, I once told people that I was afraid that what was happening was, for a while the scientists were running the internet, and then it was the lawyers and the commercial people, and now you have the marketing people that seem to be running it. But I think that by and large, we might as well let people try out new ideas. Many years ago, ICANN and a bunch of people were saying that it was unsafe to enlarge the top-level domains from the original 20. And I said, this is nonsense. You know, we can do it. Every technical expert said it was nonsense. And then what happened was every country came along and they said, well, we have a country code, we want a top-level domain. And so they added about 200 country codes. And then eventually people said, well, gee, the DNS doesn't really know whether a top-level domain is a country code or not, you know? And so let's have more. I think it's a fairly safe thing. I think the real question is going to be whether or not it confuses the consumer a lot. And, you know, I think the people, if they wanted to, could always go back to just using some small subset and ignoring some of the sillier ones. But it's an experiment, and it's going to happen, and we'll see. It's the only way to really have progress is trial and error, although people talk a lot about the scientific method.
Okay, so we have time for one or two more questions. Over there, please.
Thank you. Don't you think those all regulations and internet screening traffics will lead people to create internet inside the internet over, for example, Tor protocol?
Of course. I mean, from a government's point of view, to some extent, they're more worried about having a mass product out there. So a lot of the things that governments have done to try and regulate VCRs or other things is just to make the technology difficult. And the people that are the real technical experts will figure out the ways to get around it. But the other 99% won't. It's the same thing is true that there's all these people, there's all these governments that are actually protecting us from criminals using wiretaps, where encryption is really pretty available, right? So, yeah, people will use Tor and other technologies to get around it. In some ways, I think that's a healthy thing.
And probably one last question. Who's going to be the last? Nothing else? Okay, so, there you are. Last minute question.
How does it feel to be in history?
Well, I tell my children that, if you're going to work in technology and you want to become famous in history, it's not going to happen, because all technology gets replaced. So if you want to be famous 200 years from now, you should compose music, because Mozart is still famous and always will be. Whereas, people always say, well, is this DNS thing going to live forever? I say no. I regularly have people talk to me about, they usually come up to me and they say, well, I have a few ideas, and in reality they think they have a much better way to do it and they're going to replace it all. And I encourage them to think about that, because technology is replaceable. So, I have a little period in time here, but Mozart will be around for a lot longer.
Thanks so much, Paul. It's really incredible to have you here. And if you want to speak and talk later with him, he will be around. And at 2:30, we'll have a discussion panel also with him. 2:30 here at the main stage. Thanks so much, Paul.
Thanks. You've been a great audience.